Hello everyone, welcome to our new episode. So in this episode I'm going to talk about dynamic monopoly problem. This problem has some resemblance with what we observe in real life. So you'll see, but obviously it's a way to simplified version of the reality. Well, even the simpler version is actually highly complicated, and so I decided to shoot a specific video for this particular example. Obviously, our purpose is to find the subgame perfect Nash equilibrium of this game, but as I said, it's a complicated game and so deserves a specific attention. So let's first describe what the game is, what the strategies available to players are, and then talk about how we can solve and how we can find the subgame perfect Nash equilibrium. All right, so here's the problem. So we assume that there's a single firm, a monopolist, and that single firm sells smartphones, cell phones. So suppose that there are 4 customers. All right, so that means there are 5 players in this game. And these 5 players interact in 2 periods, period 1, period 2. You can think of this as year 1, year 2, and then the game is over. But I'm going to call them period 1, period 2. Each customer benefits from owning a smartphone, all right? They use it, they call their customers, whatever. But everybody enjoys sort of owning a smartphone on both periods. Each customer benefits more in period 1 than period 2. I mean, think of this as a cell phone company, smartphone company is producing something new, and so everybody would like to have it in, as early as possible. So year 1. Well, obviously owning it in year 2 is beneficial, but it's not thrilling to own it or being one of the early owners. You see what I mean? So owning the smartphone is beneficial in both periods, but everybody prefers to own it. I mean, everybody attaches more value, more benefit of owning it in period 1 than in owning it in period 2. However, customers benefits in different levels, all right? So their willingness to pay, how much they are benefiting out of this cell phone may differ. So what we're going to do, we're going to assume that there are L types, low types, and high types. So low and high here, basically how much benefit they're going to derive from owning the cell phone. And we assume that there's a firm, right, monopolist, and then 4 customers. 2 of them is high type and 2 of them is low type. And the type low and type high, they have different benefits. So here, this is year 1, this is year 2. So in year 1, for example, the high type's benefit is going to be 1,200 units. All right, meaning you can interpret this as the 1,200 units of benefit high type is going to derive from owning the cell phone or smartphone in year 1, and additional 500 units of benefit or utility from year 2. Okay, and then so basically total 1,700 units. Or, if you like, you can just call them dollars. So $1,700 is how much type H is willing to pay for this cell phone and own it for 2 whole period. Type low, however, is willing to, is benefiting only 500 units in period 1 and only 200 units in period 2. All these information are common knowledge, all right? So the monopolist knows who is high type, who is low type. In reality, we don't really observe that. But trust me, not knowing this makes things much more complicated. So all of these information is common knowledge. One thing, the monopolist cannot price discriminate its customers, meaning you cannot charge high price to some customers and low price to some other customers. You have to charge same price to all customers. Price discrimination is usually illegal. At least, first degree price discrimination is illegal. Obviously, there's much different ways of price discriminating, and in fact, this problem is representing one of the ways. What is that? Well, the monopolist cannot price discriminate. However, it can discriminate its customers in different years. So what does that mean? That means as a company, you can charge high price in period 1 and then decrease your price in period 2. And so by doing this, you basically discriminate the customers. Who are willing to pay more can buy it in the first year, and who are willing to pay less are actually have to postpone their purchase to second year. You see what I mean? So this is kind of the discrimination the monopolist can do. And in fact, this is exactly the game we are going to analyze. So here's the game. At the beginning of the game, in period 1, the firm selects a price, P1. So firm selects a price, P1. Obviously, it can be 0 or very large. Infinity, again, is not a number, but I just put the boundary there. So the price can be anything between 0 and 1. So I'm going to call it P1. After this, after the firm selects the price, which obviously should be greater than 0, the customers observe this price and they then simultaneously decide whether to purchase at this price or not. All right? So the 4 customers, they basically decide, so the 4 customers decide to purchase or not. All right? So each customer has this strategy or option to choose purchase it at a price P1 and not purchase it. Okay? And not purchase it here means basically waiting for the second period. All right, so once a customer purchased the smartphone, she doesn't need to make another purchase in period 2 because she can use the smartphone in both periods. So here the purchases are once and for all. Okay, so once you buy it and pay the price, that's it, you can own it. If you buy it in period 1, you can own it both periods. If you buy it in period 2, obviously you can only enjoy it in period 2. All right. What else? Firm has 4 units of smartphone, so customers do not have to compete with each other. That's an important simplification. So there's enough of supply. All right. If there was less supply, things could be more complicated. I don't know. But there's going to be no shortage of supply. There are 4 units of cell phone. But the thing is, the monopolist may not want to sell all of them in the first period. All right. At the beginning, so that's the end of the period 1. At the beginning of period 2, right? This is period 1. By the way, if you realize, I am not drawing a sort of a formal game tree here because it's going to be very complicated. So rather, I am just sketching the game tree. So here, this is period 1, this is period 2. Period 1 and 2 are very similar. The only thing is that obviously the number of players may be different than it is going to be different than the number of players in the first period because some customers can actually buy the good and so basically they will be out of the market. At the beginning of period 2, firm selects another price. So once again, firm selects a price between 0 to infinite and some price, we call it P2. After observing this price, any consumer who did not purchase the smartphone in period 1 may buy one at price P2. So once again, customers decide simultaneously and independently whether to purchase at price P2 or not. All right? If a consumer doesn't own a smartphone at any period, her payoff from this particular period is going to be 0. All right? However, if the consumer owns the cell phone or the smartphone in a specific period, these are the payoffs for the consumers, and obviously minus the price. The price is going to be paid only once. You don't pay the price in 2 periods. All right? That's it. So if you purchase the smartphone in period 1, you pay P1. That's it. In period 2, you do not pay anything. You just enjoy the benefit. Okay? So be careful about that. Question is, what is the subgame perfect Nash equilibrium prices in period 1 and 2? So what is P1? What is P2? The SP&E prices, obviously. Okay? So that's the question. Well, even describing the question took 10 minutes. So let's try to analyze it. But before starting analyzing, I think we need to understand few things. All right. So for this reason, I am going to sort of describe some examples. So let's suppose P1 equals P2 equals, I don't know, 900, okay, dollars. So let's suppose what's going to happen. So I need to find the optimal strategies or I need to sort of think about the optimal strategies for the buyers. I am doing these exercises so that I understand the dynamics in the game, get familiar with the game, and then solve it. I can't solve a game unless I am familiar enough with the game. All right, so you should do these exercises for each game you're planning to solve. So therefore, I just randomly picked P1, P2 being equal 900. All right. So what does that mean? So here, if P1 and P2 are 900, what is going to do these customers? Well, remember there are two type L and there are two type H. And, both H types and both L types players are going to behave exactly the same way, right? I mean, because the price is the same for everyone. And so if one H type sort of buys this good, well, the other should also buy this good, right? I mean, it should be optimal for him to buy this good as well. Here, there's one important assumption is that whenever, and you can always make this assumption, at least for this course, whenever consumers are indifferent between buying the cell phone, buying it, or not buying it, well, then we're going to assume that they will buy it. Okay? So whenever they're indifferent, so therefore, the expected payoff of buying it equals the expected payoff of not buying it, then what the heck are they going to do? Normally, buying it and not buying it, both are best response. So I'm going to break the tie. So for simplicity, trust me, I'm going to assume that whenever they're indifferent, they're actually buy the good. All right? So they will not buy the good if not buying, the expected payoff of not buying is strictly higher. All right? So that makes things much simpler. All right, so here in this example again, P1, P2 being equal and 900, let's look at player low type. So he's going to think the following. Look, if I buy this good, I'm going to pay $900 or 900. I mean, these are utility levels, okay? If it makes sense for you, or if it makes the lingo easier for you, just which is what I'm going to do, put $sign in front of them. But they are actually utility values. So if I buy this cell phone, smartphone, this period, P1 is 900. I'm going to receive 500 plus 200 benefits, 700, minus 900. So it's minus 200 net benefit. If I do not own this cell phone, my utility is zero, right? So therefore, at this price, I'm not going to buy it this period. In the next period, well, once the period one is over, my benefit is owning of this cell phone is $200. So at that price, I will not buy it at all. All right? So therefore, if these are the prices, well, then the optimal strategy for the low types is not to buy this cell phone at all. All right? What about the high types? Well, the high types, they look at and say, hey, today if I buy it, my benefit is going to be 170, right? I mean, 1200 plus 500, 1700, I'm sorry. So this is my benefit. And the price I'm going to pay is 900. So I have 800 net benefit, which is higher than not owning this cell phone, which is zero. Or alternatively, I can not purchase it today, purchase it next year, next period, but this time my payoff is going to be 500 minus 900. So it's going to be minus 400. So you know what? I'm not going to delay this cell phone. I'm going to buy it today. All right? So that means under those prices, only the high types will buy and the low types will never buy it. Question is can this be an optimal strategy for the monopolist? Obviously not. Why? Well, because the monopolist cannot sell to all 4 customers. Already monopolists have 4 smartphones. The monopolist can sell only 2 of them. So the remaining 2 is basically garbage, which means cost. So the monopolist can actually increase its profit. How so? Well, the monopolist can say, you know what, in the second period, 900 is way too much. So my customers, the low type customers, are not going to buy it in the second period. They will never buy it. So why not decrease the price in the second period? So for example, P1 equals 900. Again, I mean, why 900? Again, I just randomly picked it. But at least I learned something. I learned that when P2 is way too high, you cannot really sell it to the low customers. Okay, well then let's keep P1 900 and decline P2 to a lower level. How low can I go? Well, you know what? In the second period, these guys, these low types, will never buy this cell phone if the price is higher than 200, right? Because the maximum willingness to pay for them of owning this smartphone for one final period is 200 units. So therefore, the highest price I can charge is 200. Remember, whenever they're indifferent between buying and not buying, I assume that they're going to buy it. So therefore, I know that it doesn't have to be $199. So even if I charge $200, I assume that they're going to buy it and derive zero utility. Okay, so if this is the price scheme that I am thinking of following, and I am not planning to revise it, let's suppose. Question is, are these buyers, I mean, how are these buyers going to behave? So here's the thing. Firm 1 is going to, oh, by the way, obviously there's one very important question. When the firm decides those strategies, do they announce those prices? Well, no, they don't. Remember, firm 1 picks price P1, and then consumers decide whether to buy it or not, and then firm 2 decides the price, and so on. So therefore, when consumers decide whether to buy this cell phone, smartphone in period 1 or not, they actually do not know what the price of this smartphone will be in period 2. All right? However, we are looking for equilibrium strategies. All right? What does that mean? That means, suppose that everybody, so remember, this is how we check equilibrium. So S1, S2, Sn. So I have 5 players, in fact. So these are the strategies of the players. So how do we check equilibrium? Nash equilibrium. Suppose that for player 1, S2 all the way Sn is fixed, and player 1 knows that. Question is S1 best response to those strategies? Remember, this is how we check Nash equilibrium. So therefore, yes, when they play this game, in period 1, when consumers decide to buy this good or not buy it, they clearly do not know the second period prices, because firm is not announcing both periods prices. However, the checking Nash equilibrium, or SPNE, means fixing the other's strategies. Do I best response or not? So that is the idea. So therefore, when we check if something is Nash or not, we actually treat it as if players know the other's strategy and then trying to best response it. But don't forget where this is coming from. It is coming from the fact that these are in fact beliefs. So a strategy profile is a Nash equilibrium means given that player 1 believes the others are going to act like that, is he best responding? And same for player 2, same for player 3, same for all players. And then we say, look, given all players' beliefs, everybody is best responding. All right, so that's best responding, simply. And then the Nash basically means that everybody's beliefs actually coincides with what their opponents will do. All right, so that's what Nash is. So for that reason, I assume as if like player actually, the consumers know what the second price will be. They don't know it. They just believe that this is going to be the second period price. If this is what they believe, what are they going to do? What is their optimal decision? Well, here's what they're going to do. Well, period 1 price is 900. Still, it's more than 500 plus 200, 700. So low types will not buy this good in period 1, but in period 2, they will buy it. So L purchases in period 2. Very good. So I can sell, as a monopolist, I can sell my product to the low types in the second period, but fine, I can sell. Well, what about the high types though? The high types are going to do the following. Look, if I buy as a high type, if I buy today, buy period 1 I mean, I am going to get benefit 1700 and the price I'm going to pay is 900. So my net benefit is going to be 800. Clear? Yes. However, if I do not buy today and if I wait, what's going to be my benefit? By period 2. Well, then I'm going to get benefit 500 and the price is going to be minus 200. So therefore my net benefit is going to be 300. So you know what? My benefit is going to be, net benefit is going to be much higher if I buy in period 1 rather than waiting. Obviously, if I don't buy, my payoff is going to be 0. So you know what? The high types buys in period 1. Well, very good. Well, the question is, then it seems like, players are literally, as a monopolist, you can sell all these for smartphones. That's brilliant. But the question is, are these prices really the profit maximizing prices? Can you achieve as a monopolist better than this? Well, yeah, good question. So you see how we iterate the idea of SPNE or the optimal solution. Well, let's think about it. Can we do better than this? Well, no, yes, we can. I know. How so? Well, look, I cannot charge a price higher than 200 in the second period, but in fact, I can charge price higher than 900 in first period. And I should charge higher price. But why? Well, look, these guys, these high type guys are actually benefiting 1,700 units, meaning they're willing to pay $1,700 in period 1. And I am charging only $900. So maybe I should charge 1,700 in the first period. All right. And then charge 200 in the second period. Should I do that? Let's go back to how low type and high type will behave, right? Because depending on the price, the consumer's behaviors will also change. So what does that mean? That means players observe that the price is $1,700 in period 1, and they believe that the price is going to decline to $200 in the second period. What's going to be the optimal behavior of these consumers? Well, the low types will certainly not buy it in period 1 because it's even more expensive, but they will certainly buy it in the second period. We know that, so this is not going to change. What about the high types? Well, are they going to still buy in period 1? Let's check. If they buy in period 1, they're going to get this much benefit, but the price they have to pay is going to be this much. So therefore, they're going to get 0 benefit. This is still better than not buying this cell phone at all, right? However, don't forget, the high types have also option of buying in period 2. So if I buy in period 2 as a high type consumer, I'm going to have 500 utility level and I am going to pay only 200 and I'm going to get 300 units of benefit, which is higher than 0. What does that mean? That means actually, if you charge those prices, there's no way you can sell high types, these smartphones, in period 1. They are actually going to wait as well, period 2, and they're going to buy this smartphone in the second period. So what does that mean? H buys in period 2. So what's going to be the profit for the monopolist? Well, the monopolist profit is going to be, everybody's buying in the second period at a price 200 times 4 customers. So it's going to be $800 net profit. By the way, what was the profit when the price was P1 equals 900, P2 equals 200? Well, there the profit was, remember, high types were buying in period 1, and so it was 900 times 2 customers plus 2 guys are buying in period 2, so therefore this is 1800 plus 400, 220. 2200. Definitely higher profit. So by increasing the price, I actually reduced my profit significantly. You see? So you probably start seeing the trend. You can increase the price in period 1, but you know what? You should not increase it too much. Because if you do that, you are going to lose the high type guys in the first period. You want the high type guys to buy it in the first period, not in the second period, because the second period price is going to be very low. So how can I make high guys buy this smartphone in the first period? Okay. Here's what I should do. You know what? Remember, these guys are willing to buy, and in this case, going to benefit 1700 units of benefit, right? However, let's keep this price fixed. It's $200. So what's going to be the benefit if they buy in the second period? It is 300. So the question is, I would like to charge a price in the first period where, the benefit minus cost is going to be greater than or equal to 300, which is the payoff of waiting for the second period. All right? So, therefore, the P1 has to be less than or equal to 1400. So here there's one more assumption. I did not specify it, but again, these are all safe assumptions you should always, and you should always do in this course. When P1 is exactly equal to 1400, this guy is going to be indifferent between buying in period 1 and buying in period 2. So what is he going to do? Without loss of generality, you can assume that he's going to buy in period 1. Okay? So this is what I'm going to assume. So that means I'm going to look at the third scenario. And this is the scenario, 1400 and 200. What about this price? Meaning firm 1 charges $1,400 and everybody believes that it's going to charge $200 in period 2. First off, what would be the profit in this case? Simple, 1,400 times 2, because both consumers are going to buy it, the high types will buy it, plus 200 times 2. So what does that mean? This is 2,800, this is 400, so that's 3,200. Much higher than 2,200. So it seems like, this is definitely a higher payoff, a profit. And if you again check, the low types will not buy this cell phone in first period, they're going to buy it in second period, and the high types are going to buy the cell phone in the first period because they are driving, remember, 3 units of utility, which is exactly the same of buying this cell phone in the second unit, but we assume that they're going to buy it in first period. So that seems like that is the best profit the monopolist can achieve. Is it really the case? So the answer is yes. This is in fact the subgame perfect Nash equilibrium strategy. P1 and P2 in this game, and it's the unique subgame perfect Nash equilibrium strategy. All right, so this is how I solve this game, but this is how my thinking process works. So what I'm going to do next is basically formally write down the solution and show that this outcome is in fact the only subgame perfect Nash equilibrium outcome of this game. All right, so wait for this one. Okay, so welcome back. Now I'm going to formally solve this game. The previous solution is definitely my thought process. The thing is, if you can write it down or describe it plainly and clearly, that would be a perfect solution. But here is the safest formal solution, how it would look like. So what I'm doing is basically doing or applying backward induction. So I'm going to start from period 2. So in period 2, let's suppose that P2 is the given price. All right, so P2 is given. Remember, the final players are the consumers. So how are they going to react to that P2? Well, who is remaining? I don't know. But what I know is that the high type will purchase if and only if P2 is less than or equal to 500. Agree? So this is his optimal strategy. Otherwise, it's not going to purchase. The low type will purchase, both low type will purchase if and only if P2 is less than or equal to 200. Clear? All right, very good. So here's the thing then. Well, what is going to be, and now I sort of found what the optimal strategies will look like for the consumers in period 2. Now, what is going to be the optimal strategy in period 2 for the monopolist? Meaning, what is the optimal P2? What is optimal P2? Okay, so here, there are obviously different subgames I need to consider, right? Because who remains in this market is going to determine what the P2 will be. So how many cases are there? There are in fact many cases, like maybe both H-type and both L-type remained in the market. Or maybe 1H, 1L remained. Maybe 2H, 1L remained. Maybe 1H, 2L remained. And so on and so forth. All right. So, but one thing I would like to say the following. So, can I have, for example, a subgame where, 1H and 2L remains, which means one H type purchases, one L type does not in period 1. I mean, this is a legitimate subgame. But the question is, I'm not trying to find subgame perfect Nash equilibrium strategy profile. I'm trying to find subgame perfect Nash equilibrium outcome. Meaning, only thing I care about is P2, and the only thing I care about is P1 later. So here, in the subgame, I don't know what P2 is going to be, all right? Because again, I do not want to describe what P2 should be at every subgame. I just want to find the optimal P2 on the equilibrium path. Well, this subgame, what I would like to say is that it is a legitimate subgame, but it's not an it cannot be on the equilibrium path. What does that mean? That means on equilibrium or in equilibrium. In equilibrium, we can never reach to a subgame where one of the high types purchase in period 1 and one of the high types, this is high type, I'm sorry. One high type purchases, one high type doesn't in period 1. This cannot be the case in equilibrium. Why? Here is why. If high type purchases, that means purchasing in period 1 gives him better profit, a better payoff than purchasing it in period 2 or not purchasing it at all, because he has 3 actions, right? So therefore, if he's purchasing, he should have a strictly higher payoff than these 2 other options. So if one high type has strictly higher payoff, well, the other high type should also have a strictly higher payoff. But there's also another option where the high type is indifferent between accepting today, accepting in period 1 and or with accepting in period 2. If he is accepting, if he's indifferent between these 2, well, then maybe one high type accepts or so purchases in period 1 and the other guy purchases in period. So this can be an equilibrium. But remember the simplification assumptions we had. Whenever players are indifferent of purchasing today or now and not purchasing, they will always purchase now. All right? So that is an assumption. And trust me, it's a simplification assumption for that reason. So therefore, if one guy is indifferent, one high type is indifferent between purchasing and not purchasing, So he is going to be buying, but all the high types will be buying. What I want to say is the following. In equilibrium, we will have both high types. The legitimate, in equilibrium, the subgames are going to be the following. 2H, 2L, meaning none of the consumers purchase this good in period 1. All right, so this is one case. It's going to be 2H, meaning the low type consumers didn't purchase it in period 1. 2L, meaning the high types, only the high types purchase it in period 1. And then, let me denote it O, which means basically there's no player. But if there's no player, the P2, what is it going to be? Well, I don't know, right? P2 is, there's no consumer, so therefore the choice of P2 is irrelevant. Okay, because the game will be over in period 1, all right? So we will not have a subgame like this. So this is not really a subgame. All right, so therefore there are 3 subgames. Again, we are trying to find the optimal P2, given that in this subgame, this is how the consumers will behave. But before this, I need to understand who purchased this smartphone in the first period. So again, nobody, only the low types, only the high types. Okay, so if this is the case, right, meaning both high types and the low types remained in the second period, what should be the profit maximizing price? Well, simple. Look, price less than, above, so if you like, you can draw this. So this is P2. So there are 2 thresholds, 200 and 500. Price above this, profit is going to be 0 because nobody's going to buy it. In this range, strictly higher than 200, but less than or equal to 500, only high types will purchase it. So the profit is going to be 500 times 2, $1,000. And below this, meaning equal to 200 and less than, what's going to happen is, obviously, I'm sorry about this. So this is not going to be 1,000. This is going to be 2 times P2. All right, so P2 is in this range, 200, 500 range. So whatever P2, it's going to be 2 times P2. And obviously the maximum can be achieved if P2 is equal to 500. That was my point. There's no point of charging $250 or $300 or $400. Why? Well, because all those prices, 250, 300, 400, all these prices, the low types are not consuming anyway, and they're not purchasing anyway. You're just selling it to the high types. But what is the point of charging them $400? You know they're willing to pay $500, so therefore charge them $500. You see what I mean? So here in this range, in this sort of the optimal P2 is going to be 500. And here again is like the optimal, so if the price is less than 200, the profit is going to be 4 times P2, right? But the P2 is at most 200. So that means here in this range, meaning if you charge a price 200, all right, so P2 is equal to 200, the profit is going to be 200 times 4, $800. But if you charge 500, so if P2 is equal to 500, you can sell only 2 smartphones and your profit is going to be 1,000. So therefore, in this case, when nobody purchased in the first period, the profit maximizing price is P2 equals 500 and profit is equal to 1,000. Okay? Good. What if only 2 H guys remained? Well, same thing. P2 must be 500, and so profit is equal to 1,000. What if 2 L guys remained? Well, P2 has to be 200, and pi is equal to 400. Okay, that's it. Very good. Well, what am I going to do with this? Well, you'll see. Now, I am done with period 2 analysis. I will move up to period 1. So period 1. Okay, So period 1. Now I would like to first understand how my consumer's behavior will be. All right, so the H type and L type. So how are they going to do? Can I say H type will purchase if and only if pi 2, or I'm sorry, now it's pi 1. Pi 1 is greater than or less than some number? Is it going to be that simple? Not really. Why not? Well, because what H-type's benefits or payoff will depend on, obviously, what the second period price will be. All right? So what does that mean? That means if, for example, nobody purchases this good, well, then the second period price is going to be something else. All right. If the low types only purchased, well, then the price in the second period will be something else. And in this scenario, the second period price will be something else. So what I am trying to say is the following: the H type's payoff doesn't only depend on P1, but it also depends on what the other customers will do. Because once again, if they do or do not purchase, that's going to affect the second period price, and therefore the H-type optimal decision will be different. All right, so what I would like to understand here, at least the H-type or low type has 3 options. All right, purchase now, purchase in period 1, purchase in period 2, and never purchase, obviously. Never purchase. Okay? So there are 3 potential optimal strategies for a high type and low type. And so when I find the best responses, I need to compare the high types and the low types expected payoffs under those 3 potential strategies. Okay, guys. So once again, we are in period 1, and now given P1, I need to understand the best response of players, of the consumers. So I'm going to look at the high type consumers first and then the low type consumers. So the high type consumers can do one of 2 things, right? Well, one of 3 things. It can purchase in period 1, it can wait today and purchase in period 2, or never purchase. But you know what? I'm going to ignore never purchase. Why? Well, because in the second period, as you see, the price will be at most $500, which means the high type always, remember, the high type will be indifferent between purchasing in the second period and not purchasing. And in this case, by assumption, we assume that the high type will definitely purchase. All right, so whether the scenario is this or that doesn't matter. In the second period, in equilibrium, the consumers, high type consumers, will certainly consume or buy this product. So therefore, don't purchase means, it basically means purchase in period 2. Okay, same for, or at least the similar for player 2, low type. I'm sorry, I'll come to that later. So if high type purchases in period 1, what's going to be his continuation value, payoff? Well, if it purchased in period 1, remember he's going to be deriving 1,500 today and 500 tomorrow minus the price he's paying today. Well, if he purchases in second period, he's going to derive 0 payoff from the first period, but he will derive 500 units of payoff from the second period minus P2, right? We don't know what P2 will be because that depends on what his opponents are going to do. What the low types will do. But what we can say at least is the following. So what is this? This is equal to 1700 minus P1. This is equal to 500 minus P2. So therefore, high type will purchase in period 1 if and only if 1700 minus P1 greater than or equal to, whenever he's indifferent, he will purchase in period 1 by assumption. 500 minus P2, which basically means if and only if P1 minus P2 less than or equal to 1200. Okay, so if the difference between P1 and P2 satisfy this, we know that the high types will definitely purchase this good. What about the low types? Well, if the low types purchase in period 1, its benefit is going to be 500 plus 200, 700 minus price of good 1. If it purchases in period 2, well, its profit is going to be 200 minus P2. Well, obviously, 200 minus P2, but if P2 is going to be 500, well, then this is going to be negative. So therefore, this is like no purchase. So in this case, it's going to be 0. So what we need to say is the following. The L type purchases in period 1, okay, if and only if this term, 700 minus P1, is greater than or equal to 200 minus P2, which is equivalent to saying P1 minus P2 less than or equal to 500. Otherwise, if, well, yeah, I mean, let's forget about otherwise, because otherwise he's not going to purchase it. He will either prefer to wait the second period or he is going to not purchase it at all. All right? So, but by the way, we should also consider the following. Type 2 purchase in period 1 if and only if this, and obviously 700 minus P1 is greater than 0. So that basically means P1 is less than or equal to 700. Okay, is that clear? Good. So now I'm going to go to the final, the initial decision node where firm 1, the period 1, firm 1 chooses P1. So what P1 maximizes the profit. So I am going to erase this. I am going to keep this because those subgame optimal strategies are important. So if it is 2H, 2L, P2 is going to be 500. If it is 2H, P2 is going to be 500. And if it is 2L, P2 must be 200. All right, so let's keep that as well. And now I'm going to use those best responses. These are best responses as a function of P1 and P2, obviously. These are intrinsically depend on what the other players will do because, P2 is going to determine what the high type and low and the other low types are actually going to do. So what I would like to do now, what is optimal P1? All right. So here is the thing. Remember, I have a P1, I have optimal behaviors, but that optimal behaviors depends on the P1, P2 level. And there is 2 thresholds for P1 minus P2. Here there's another threshold, P1 less than or equal to 700. At this point, I don't know how I'm going to use it, but I have to make sure that my conditions satisfy this at the end. But first, here, let's say my P1 minus P2 satisfy, it has 2 critical points, right? 1200 and 500. So what I know is that if P1 minus P2 is less than this, or let's put it this way, if it is in this range, all right, meaning case 1, P1 minus P2 is element of 500, so higher than 500, but less than or equal to 1200. In this case, what we know is that high types will purchase in period 1. High purchase in period 1. L, well, remember, because P1 minus P2 is less than 500, they will not purchase. Will not purchase in period 1, Okay, so good. Well, then what? What happens, so here, be careful. The high types purchase in period 1, low types will not purchase in period 1. So in period 2, only 2L will remain. In which case, I know that the optimal price must be 200. So what does that mean? That means whenever P1 minus P2, which is equal to P1 minus 200, is less than or equal to 1200, but more than or equal to, 500, which means whenever P1 is greater than 700 and less than or equal to 1400, this is the scenario. H is going to purchase in period 1, L is going to purchase in period 2, all right? And I know that the H types will not purchase in period 2 because I already checked this. This P1 minus P2 less than or equal to 1200 means player 1 actually prefers, the high types actually prefers to purchase it in period 1 rather than purchasing it in period 2. All right. So therefore, if P1 is in this range, what's going to happen is that both high types are purchasing in period 1, and so the profit is going to be 2P1 and then 2 times P2, so 2 times 200. But you know what? P1 can be at most 1400, and hence the maximum profit is going to be when P1 is equal to 1400 and P2 is equal to 200. This is exactly what we found, remember? And this is exactly the profit maximizing prices when P1 minus P2. So, I'm sorry, let me take it back. This is the profit maximizing let me put it this way. We have not yet shown that this is profit maximizing. What we have shown that in equilibrium, if P1 minus P2 is in this range, well, then that is going to be the profit maximizing prices. But maybe the profit maximizing prices are not in this range. Maybe it is in this range, meaning P1 minus P2 is in fact less than or equal to 500. Maybe equilibrium is there. You see what I mean? We have to check that. I mean, I know this is the equilibrium, but let's check that. So let's leave this guy here. So this is the case 2. P1 minus P2 less than or equal to 500. So what happens in this case is, according to my calculations, high types, right, purchase, both of them, and then L types also purchase in period 2. Agree? So then what does that mean? That means in period 1, I'm sorry. In period 1, right? Well, what does that mean? That means the game will be over in period 1, and hence P2 is like 0. I mean, there's going to be no price of 2. So that means P1, whenever P1 is less than or equal to 500, actually both high type and low type will purchase it. Obviously, because the firm can sell to all 4 customers, profit is going to be 4 times P1, but the P1 can be at most 500, all right? And this profit can be at most 4 times 500, which is 2,000. But don't forget, here the profit is at most less than or equal to 2 times P1, which is 1400, 2800 plus 400. So this is 3200, which is higher than 2000. What does that mean? The conclusion. The conclusion is the following. In equilibrium, P1 minus P2, the difference between P1 and P2 must be less than or equal to 1200. In fact, we pin down the exact values. In equilibrium, P1 has to be 1400, P2 has to be 200, because those prices maximize the profit of the monopolist. And so these are the only subgame perfect Nash equilibrium strategy, subgame perfect Nash equilibrium outcomes of this game. I hope that was clear.